In this example, we're going to be talking about integrated rate equations. The problem reads, a second-order reaction A to 2B is found to have a rate constant of 1.3 times 10 to the negative 2, 1 over ms. How long does it take for the concentration of the reactant to drop from 0.3 molarity to 0.02 of the molarity? The first thing we need to do is determine our given. Our first given is that this is in a second-order reaction. The rate constant is 1.3 times 10 to the negative 2 with its units. And we are given the reactant drop from 0.3 to 0.02. Since we are told that this is a second-order reaction, we know the equation for this is 1 over the concentration of A final is equal to KT plus 1 over the concentration of A initial. Knowing this equation, we can set these terms with their actual concentrations. So for final, how long does it take for the concentration of the reaction to drop from this to this? So 0.02 would be our final. 0.3 would be our initial. The K would be 1.3 times 10 to the negative 2, leaving us to find what T is. Then we can plug in everything. So final would be 0.02 K would be 1.3 times 10 to the negative 2 plus 1 over the initial. Our next step would be to simplify. 1 over 0.02 would be equal to 50. 1 over 0.3 would be 3.33. And now we would solve for T. So the first thing we can do is subtract 3.33 minus 50 in order to try to isolate T. So that would come out to 46.666. Now we can divide by K. The T should be equal to 3589.74. And since T is in seconds, we can go ahead and round to 3,590 seconds. And this would be our final answer.